Now, if you're looking to build your own custom frame, you're going to want to consider the rake angle. Now, this is going to be based on the rolling chassis, which is the frame on top of the wheels and the suspension, with everything really assembled. But the rake angle within the frame itself is going to be very critical, because once you've welded that frame together, you now have no adjustability. Now, if you don't know the importance of rake and trail, then I recommend checking out this video where I explain the basics of motorcycle geometry and dynamics. Now, of course, we can collect a lot of data for various different bikes, so we can get a kind of target for what kind of rake angle we think is going to suit our motorcycle, but we're not going to get the point from this data collection, because every motorcycle is going to be different in many different ways, from the geometry to the weight distribution, the rider, the ergonomics, even the engine itself. Everything is going to be affecting the handling of the motorcycle. So once we actually have a complete motorcycle, especially through the development phase, it is very important that we have some adjustability within the chassis so we can fine-tune and improve the handling if we find any issues. And in production and with custom bike building, we're going to do that in the headstock with things like with inserts or cups, which can help to give us the ability to increase or decrease the rake angle and potentially even shift the steering axis as well. I'd just like to ask, if you do appreciate the content here, that you consider liking and subscribing. I've been posting here for about a year now, and I've genuinely enjoyed making these the more technical videos that I post here. And to see 600 other people have subscribed is quite motivating. So I'd like to set a challenge of, say, 800 subscribers by the end of August. And I'm going to be trying to put a few more videos out this month with some increased variety and hopefully some more entertainment value as well. So if you're interested in following this channel, then please consider subscribing. I've had to reshoot this on another day because the focus was awful. So I've actually been working on a headstock assembly here for other purposes, but I think it's a good opportunity to talk about this now. So let's take a look. Okay, so this is my steering head mock-up. So we have the lower yoke here. And we see I have some design features here. I'd like to show you how you can model those. I've seen this kind of design on some more premium aftermarket parts. So take a look at that in CAD later on, or you can click this button here and skip straight to that part. Then we have the stem, so stem in. And from there we then have the lower bearing seal. I haven't printed the seals, but we do have some bearings that I printed off. This is I've gone with the tapered roller bearings, so slide that down. Then we have the headstock tube. So I haven't finished putting all the different features on here, but I have pressed in the races, and I have made the mistake of sizing the internal diameter based on the internal diameter of the bearing itself, the lower bearing, and not the race. So I can no longer remove the top or bottom races, so be careful of that if you're planning on doing something similar. So we drop our headstock tube down, and we have some free movement. On top of here now, I'm just going to drop the representation of the stanchions. On top here we have the top bearings. Now these actually turned out really nicely. You can hear that rattle where they're all moving around, sliding on this very nice bearings printed off here. So slide that down. This is our top bearing, and then we'd have some combination of lock nuts which come together. Now, to get these threads to work, I actually had to increase the scale of one of my parts, and I accidentally increased the vertical scale as well, so it doesn't all fit together as I wanted. So we're going to skip the assembly of multiple parts and the lock ring that would prevent the two parts from rotating away from each other. Then we have the top yoke. See if I put that on here. And then the top nut. So this is my steering assembly currently. So this is now going to be a fixed rake angle if I was to weld this into a frame. So let's assume we fully build this motorcycle, this frame up, and then we take it for a test ride and it's super twitchy and it really wants to just drop into every corner. Ideally, we'd want to increase the rake angle so that we can increase the trail, and the easiest way to do that without affecting other things would be to adjust the head angle. Otherwise, you'd be looking at increasing the diameter of the wheels or adjusting the length of the fork stanchions, dropping the whole front end essentially lower onto the forks, but you may not have clearances to do so. So by allowing us to adjust this angle just in the tube, you can achieve increased trail values, which can help increase stability. So let's take a look at what that might look like in CAD. Okay, so this is a mock-up assembly of the headstock with variable rake angle inserts. Say this is a very rough one because I haven't fine-tuned the thicknesses of, say, the inserts to the wall of the headstock, so it's very oversized. This could definitely be tuned down. Essentially what we have here, this is the top of the headstock. We have a bearings positioned in here, and the axis, or at least where the bearing seats on the axis, is going to be the same point whether it's angled in this direction or in this direction. Now if you add on the section view, you'll see what I mean. So essentially we add an angle for the seat for the bearing, and then we've also angled the side surfaces here with the insert. By retaining the position here, we minimize the amount of variation we have to introduce in the top of the tube. That means that the variation in degree that we introduce, so if we increase or decrease the rake angle by 1.5 degrees in either direction, for example, that's going to be substantially different at the other end because of the length of the headstock. So it's 180 millimeters in this case. So if you can see, looking at the center line, we've gone fairly far off of it. So as I said, there is some fine tuning here, so it's not going to be quite as substantial as this. But the reason we introduced the large variation into the bottom of the tube is because that's going to be in a more discrete location. The top of the tube is right in front of the rider's nose, so we don't want to affect this too much visually. This part is going to be more discreetly hidden behind the forks, and you know, you shouldn't really see it, and it shouldn't really be too noticeable. So what I've done here with the insert is I've added this boss feature, which I've also cut out of the headstock, and that's going to help locate and orient these inserts. They can also be swapped 180 degrees, so that's how we get our plus or minus 1.5 degrees from this particular set of inserts. Of course, we can have any number of variations as long as it's going to fit within this headstock tube. So whilst I've gone like this kind of compact insert method, there are other methods or other kind of cups that are used in custom bike building. So we'll take a quick look at what we can see online. So just a quick search for motorcycle headstock cups, and you'll find things like this. It's essentially eccentric cups which are going to be slotted into the headstock, and you can see that the surfaces that the bearing is going to be pressed onto are at an angle, very similar to the idea of the inserts. It's all going to need the same kind of principle of introducing that angle for the headstock, for the head bearings to sit into. So if you could build two, where your first one is the prototype, your first one could have some adjustability built into it, and once you find the ideal condition, your second version would be your more fixed condition. So I really wanted to highlight that it's probably quite a critical point to try and include or introduce some adjustability into your custom builds. with them being custom builds, you don't really know how they're going to be handling once you finish building it, and you want to have some adjustability so that you can try and control and improve the conditions if they're not so stable, because unlike production, you're not running a mule bike, a test prototype, as you develop the motorcycle. You have this one bike that you're developing, you're building up, and then it's on the road, and there's not much you can do in terms of adjusting the frame at that point. So look for things like this that you can help include some adjustability in your frames. And for things like your ergonomics, your rear sets, handlebars, that's a little bit more easier, but also consider things like that as well. I mentioned I wanted to show some design features in the headstock, so I haven't made this as beautiful as it could have been, but I just wanted to show how we can make things like this. You see, if we use a plane on an axis or an edge, we can then draw a sketch on that to help trim or cut away a chunk of material. But once we've cut away that chunk of material, we're then limited to chamfers and radiuses. So what we can do, once we've cut away, or instead of cutting away that material, we can extrude a block, keep it as a separate body, and then on the body we can then create a sketch like this, and then extrude that and merge it with the block. So then we get some geometry like this. So that's how we can start merging and cutting away material to make some more interesting shapes. Okay, so I hope this video has given you some food for thought, and I'll see you on the next one.